Okay, for this first part of our finals review, we actually did a teeny tiny bit of review before the top 20 stuff, and we reviewed this. And so I'm reminding you, at the beginning of your packet, you have questions like this. And the start, well, I know you know that the starting amount is 4, and I'm guessing almost everybody had that one right. This one, I warned the kids that it was not 2, and it was not 20, and it's not 200%. You got to think of this 2 as a 1 plus 1. Why do we compare it to 1 like that? Because multiplying by 1 would keep it exactly the same. So this is the growth part. And is that 10% growth? No, that is 100% growth. So that was the growth rate. Whatever's above 1. Okay? So in this case, it was 1 plus 1, so it's 100% growth. Think about it. You times by 2. Yes, it doubles, but did it grow 200%? No, it grows 100%. It's an easy thing to get confused. All right, and then how long does it take to double? That's this number. Because if you put in a 5, you like say 5 years, here's a 5. Look, now that's to the power of 1, and there's a 2 in there. That makes it be 2 to the 1, which makes it double. You're timesing by 2 then. Make sense? Okay. All right, so there could be questions, and probably will be, on all of those topics. Now let's go into the packet itself. It looks like this, and when you look at this, I hope you now know that it's not 8% growth or 800% growth. This would be a 1 plus what? Don't overthink it. 1 plus 7. And so that means what percent growth? 700% growth. All right. And the starting amount was 7. The growth rate, 700%. What else might they ask you? Initial value, that's the same exact thing as start value. The base is the 8. That's the base. Is it growth or decay? As long as you're multiplied by something bigger than 1, it's growth. But see, like here, we know it's less than 1 because they take 1 and subtract something from it. So then that's 15% less than just multiplying by 1. So that's decay, and it's 15% decay. Okay, good enough on that page. Let's move on to expanding. We just did these, but still a lot of kids struggle with this. Fourth root. If you know, you know. This kind you change to x over y to the power of what? Apparently some of you don't know. Fourth root means 1 over 4. Remember, if you have a fraction power, the bottom is the root part, the top is the normal power part, and if there is a negative, which there isn't in this case, but if there's a negative in front would make it flip or reciprocal. But there's no negative for this one, so there's no flipping happening. But do you get if this had been a 1 over all that? Then you'd have had to use a negative power. All right, so let's just check you quick on your powers, because do you remember me saying that kids that can handle weird powers are gonna be fine on the logs test? Well, same thing on the final. Would you please find this one? It's letter D on the second page of the packet. Take a second, try this one with me. Now, what's the point, server? Well, it's expanded, but it's going to be hard to expand it unless you know what fraction power that is. And then you expand it into 2 logs, ln this and ln that. Or, wait, server, you always said to say log base e. Okay, I will follow what I said. Whenever I see ln, I make it log base e. And why do I have 2 of them? Because I'm expanding it. Riker, should this be an add kind in here or a subtract kind in there? Subtract because why? Because it's divided in there. This is subtract. And then Riker, this would be an x, but a cube root of x, so you made it an x to the what?
1/3.
Yes, and then that goes where? To the front. You have to do that when you're expanding? Yep. And this y to the fourth, very common for the kid to just forget. So I tell kids to go back and look at the argument and see, could I expand that more? Nope. Could I expand that more? Oh yeah, I could. So therefore, this 4 has got to move. Goes to the front. Now the argument can't be expanded anymore. And there would be your final answer. It's expanded all the way. Remember, the directions are always expand and simplify. If this had been an e instead of an x, then I would have known that log base e of e would have just been 1. And 1/3 times that would be 1/3. Okay, so there's a little reminder on log expands. How about evaluate? What in the world are you supposed to do here? I don't like the wording of that, because it doesn't really, tell you what to do. And this one's simple enough that I could see it using those directions, but I think I would have said simplify. I think that's how I would have said the directions. Simplify. Okay, so how do I simplify this? Well, my first rule with ln is don't use ln. And as soon as you write this as log base e of e to the 4 minus x, I hope you go, oh yeah, this whole thing is equal to the exponent on this, and so therefore that is a lot simpler, 4 minus x. Get what happened there? Because I could see the bases were the same, and the only way I could see the bases were the same is if I had written in log base e. So same, anytime you have ln, write log base e. This one's a log that doesn't have a base, but you're supposed to know what its base is then. And again, it simplifies down really quick. This one depends on your knowledge of powers. If you can make that x to a power, then you'll have the answer. Boom. All right. And there's a key for all of this, so of course you can check these if you want to off the key. Condensing. Condensing, of course, means to get it down to 1 log. We will always make them so you can get it down to just 1 log. And again, I like log base e for the ln's. And then this little 2 needs to be put away. Goes up there. 3 gets put away, goes up there. And since it's an add, you have a times in your argument. And I hope you've got this one from there. Don't forget to put the 4 away first, and it goes up there. Same with the 3. And then there's a subtract here, so there's going to be a divide. All right, I'm hoping that the log stuff is still fresh enough in your mind that we shouldn't really spend too much time on it. So next page. This is problem 6. There will be questions like this on your final. These are all about making the bases the same or rewriting. Making the bases the same or rewrite. So I'd like you to actually put that advice to yourself here on the side. Make bases same or rewrite. So like this one, I can't make the bases the same. So I'm going to rewrite it. Let's see here. Tully, can you tell me how to rewrite letter C here?
Is it 4
To the
power of 1
Yep.
equals x 1 minus x?
That's exactly that. I call it the circle of logs. 4 to the 1 equals 1 minus x, and 4 to the 1 is just 4, so man, that's a super simple equation, and now you can just solve it. All right. I have also said if you can combine the logs, you should. Look it, I can combine those logs, so I should. And then if I get logs on both sides that have the same base, which these are both base e, I'll be able to drop those logs. But wait, combine them together first, then thinking about dropping the logs there. This one, letter G as in goat. It's tricky for a lot of kids because they're like, I can't make this into 9 to a power. That's just not working. So don't. You can make it into a 3 to a power. 3 to the 3rd. And then do the same thing to the other side. And then you'll have the bases the same. So what's 9? 3 to the 2. And now that the bases are the same, that has to equal that. Just be sure to distribute your 3. A lot of kids just go 3 times the x. Now you got to distribute it. All right, so there's some help on that page. On to the next page, graphing them. I've taught you both semesters that every time you graph, you should use your best friend in graphing, which is the XY chart. So, if you can just make enough points, any little kid can fill in the, like connect the dots. So we just got to find some dots. We got to find some points. You just got to be strategic about what you pick. Because honestly, picking like a 1 or a 2 makes this pretty hard to do. So I would pick easy things for X, like in this case, give me something that would would work nice. -3, I agree 100%. Because now look, -3 plus 3 is to the 0. And I know what to the 0 power means. It means 1. So -3 gives me, wait.
Oh, no.
It gives, you're not wrong. It gives me 1/2 to the 0 and 1/2 to the 0 power. That's what's equal to 1. So it was 1. I just want to show my work about how I got there. And this part wasn't 0. It was, 1, it was 0. But because it's to the 0 power, the final answer is 1. All right. So then I know -3, 1 is on my graph. Now from one point, you cannot tell at all where a graph goes. But I'd want you to know this was exponential decay. So I know it kind of looks like that. But one thing that's really critical is, do you know where the asymptote is? On those kind, the asymptote, when you have exponential decay, they usually look like this, and the asymptote's usually there, right at 0. And the only way it'll ever move is if there's something there. So a reminder on the side maybe, for decay and growth, the asymptote starts at, well, it's on the x-axis, so it's y equals 0. And then if you've moved it up or down because there's something here, then it'll move. But otherwise, the asymptote's at 0. That's different than logs. So exponentials, the asymptote goes like that. Just side note, if I was doing a log, do they have any on this page? No, theirs are all, I'll just wait till I get to logs. But logs generally look like this, and then the asymptote goes the other way because they are inverses of each other. So whatever's on the x-axis all of a sudden becomes on the y-axis. That's what inverses do. All right, so how would I do this one? I swear, some people make this so complicated. They make the kids graph the original and then make them move it all and then make them flip all of the points. And it's like, man, that's so complicated. I want you to know that that's a reflection, and I want you to know this moves it down 2. But man, I would totally just pick points and like stick in 0, get the answer right away. If I stick a 0 right here, then this is 1/4 to the 0, which is 1. 1 minus the 2. 1 minus 2 is -1. So there, I got a point that quick. And all you need is a few points. And did the asymptote move in this case? Yes, look at that, it moved down. Okay, so there's a reminder of how to graph. Next page. This is page 6, or at least side 6 of your packet. Problem 8. I throw in a little multiple choice because, by the way, there is some multiple choice in your test. It is not all multiple choice, but there's a fair amount of multiple choice. When there is multiple choice, you should do the problems different. You should look at the answers and go, which of these is it? Instead of going, how do I write the equation for this? Look at the answers. And ask yourself, well, the start value goes here. Wait, no. The start value is in front of it like this. And this could be a 1. And this one also could be a 1. So the start value is at, well, these are all different start values. Look at this. I know my start value is y, this is the y-intercept. So which one of these has the start value? Oh, it's right there. It's the only one that has a start value of 3. Has to be that one. Another way to say it is it's also decay. You know, this would have been growth, and this doesn't look like growth to me. So that's out. And this one's growth. So it only could have been C or D, because those are the only ones with decay. And this one starts at 3. Must be that one. Okay. I don't see any logs. How do I do it? The opposite of a rewrite is to rewrite it as a log. This one, you just say log, and you say, I know I want it to be a log, and that'll force you to think about what comes next. Oh, I guess the base. And which one looks like the base to me? The 5. And then you can start the circle of logs. Log base 5 of 125 equals 3. That's in log form. This one doesn't have a base though, so you'll never be able to do it. Okay. On to part 11. State if it's at growth or exponential decay, and they're doing some tricky stuff. 75, that definitely seems like it's decay, but then, do you remember this deal? When you have a negative in your power, that flips it. I would think of it as 3/4. That's the same as 0.75, right? And then when I have a negative in the power, do you remember that flips this over, and therefore it's not decay anymore? So if you put a negative in your power, it changes it totally. Okay. I think the rest of these are fairly easy. Next page. Page 7, problem 12. Write an exponential equation. Well, I'll remind you, all your exponential equations look like this. You put the start value here. You put 1 plus something if it's a growth, or minus something if it's a decay. And the only tricky part is, if you put a number up here, like in a fraction under the x, that'll be how long it takes, like time to grow or decay. So if it's going to take every 6 years, you put like over 6 there. We talked about that earlier. And this is your growth rate or decay rate. All right, enough on that. This page, we are starting trig. And that's the other half the packet is trig. And there is so much trig to remember. I actually debated, I thought maybe I'll just teach trig tomorrow. But there's so much trig. Like 6 chapters of trig. I can't cover that in one day tomorrow. So I got to do some today. So let's go back to the very beginning, which actually isn't this. The very beginning was when I first told you about how trig could be done in a circle instead of just in triangles. Okay? Do you remember this deal where this is 0 and this is pi, and then what was at the top here? Pi over 2, good. And then I tried to teach you to count in terms of like that's 1 pi over 2, so this is 2 pi over 2, so then what's this? 3 pi over 2, and those are called what's? Well, you could have answered quadrantal because they're all on the, like, they're the spots here that you can't make triangles for. Or you could have said that we were answering in radians. Both of those would have been good answers. Those are radians and those are quadrantals. Okay. So then if I asked you what was sine of 0, when you came into this course, you would have been like, no clue. I don't know what you mean by sine of 0. But now you know that means like, I'm going to make a triangle? No, I can't make a triangle. I got to use what's called the unit circle. So if I ask you for sine of 0, you got to go back to this little spot right here is at 1, 0 on the unit circle. And then sine is one of the letters. This may be a good moment. I'm going to give you all kinds of like notes here on trig. You want to write these down. Sine is the y over the r. And, you know, if the radius happens to be 1, then sine is just y. So of these two, which one is y? Well, the 0 is the y. So if I ask sine of 0, it's saying what's the y value? And sine of 0 would be 0. 0 degrees or 0 radians, either way, sine of 0 is 0. I know that's a confusing one because it's zeros all over the place. Let's just talk about another one. What is like cosine of pi? Well, you gotta go over here then, right? And what point is that at? Iris, what's over there? What comma what?
0, -1.
Close, -1 comma 0, because the x has to be first. So -1 comma 0. You're going to the left, -1, and then the y is 0. So that's -1 comma 0. And now if I want cosine of pi, I gotta know what cosine is. X over r. And so it's the x value, and the x value here is -1, so it's -1. And if you're like, what about the r? Well, the radius is also 1. So I could say that it's -1 over 1, you know, because the x value and the r value are both important, but the r value happens to always be 1 when we're in the unit circle. All right, so that's quadrantals. Oh wait, what about tangent? What two letters over what, and that's a divide involved, so what is it? Y over x, correct. That will guaranteed be on the final. Gotta know how to find sine, cosine, and tangent of all those weird places where you can't make a triangle. All right, but sometimes you can make a triangle, like, let's say I wanted to do sine of 5 pi over 4. Well, you gotta know where in the heck 5 pi over 4 is. Please draw it off to the side. Just remind yourself, where would 5 pi over 4 be? Hint, find 4 pi over 4. It's easier to find. Pi here, that's the same as 4 pi over 4. So that's where 4 pi over 4 is. So I obviously have to go farther. I guess that will be 5 pi over 4. I know, though, pi over 4 is our 45-degree angle, so I'm going to draw this that way. 45. And so then I know the sides for that. Next, like, really important thing is those triangles that came up over and over again. This one's the 1, 1, root 2. You guys remember that one? Do you remember the most common mistake in circle trig? Negatives. So now that I've done all of that and I've drawn my triangle and I've labeled my angles and I've labeled my sides, I go on record as saying trig is easy once you've got the triangle and all the sides and all the angles. Because now it's just sine, which goes back to the very first thing, which is SOHCAHTOA. So sine is opposite over hypotenuse. So opposite hypotenuse, -1 over root 2. Okay, so there's a little review of our normal circle trig. Now, what if they give you, not normal, what if they give you like sine of an angle equals a half? Well, then they gave me the sides. Remember, these are sides. A side ratio, technically, because you're dividing them. And this is the angle. And the angle is a variable, so it must be, that's what they want me to figure out. Then you need to remember ASTC. There's always somebody who doesn't remember what that means. That is the way to remember it. All students take calc, but trig-wise, that doesn't mean anything. What does the A mean in terms of trig? All are what? Positive. Good. And the S is supposed to remind you that sine is positive, and then tangent is positive, and then cosine is positive. So that way, if they tell you, by the way, tangent's negative, you can cross off a couple of quadrants. All right, so here's the ultimate problem like that. If you can do this problem, it covers like 5 questions about trig. So see if you can do it. If I said sine of some angle is -√3 over 2. And I drew my 3 funny, so I'm going to back up and redraw it. And don't freak out when they're weird like sides like that. You're just going to draw a triangle. And its opposite side will be negative square root of 3. And its hypotenuse will be 2. And that's negative, so that tells me the 2 places it could be. But there's 2 places it could be until I say, oh, by the way, tangent of the angle is less than 0. Now there's only one place it can be. So figure out what quadrant it has to be in, draw the triangle, always make them short and fat, label the sides, and then the whole point is what's the angle? And your answer has to be in radians. All right, this is a lot, but it's super important. Try it. I know you're probably going to get stuck, but then ask the kid next to you, like, how do you do this again? I'll show you in a sec. Okay, so I knew sine was negative. That meant it couldn't be here, and it couldn't be here, because sine was negative. Said so right there. Now, of the two places that were left, yes, I could make a triangle in both here and here. But when they said tangent was less than 0, that means tangent is negative. That means it can't be here. How many of you were in the fourth quadrant? Okay, good. Now, I need to label my sides and my angles. You need to next know that the key angle is this one. It's called the central angle. And it's from there that we can go opposite and hypotenuse. If you ever find yourself labeling the hypotenuse as negative, it's the other number that's supposed to be negative. The hypotenuse isn't supposed to be negative, ever. Okay, then you should know, oh, 1, 2, square root of 3, I know that one. And this is not the 30. I memorized that when you're across from the 1, like this is across from the 1, that one's 30. So then if this is a 90, that one must be 60. But if you said 60, it would be totally wrong, and for multiple reasons. One would be that we're supposed to be in radians, and the other would be that you're supposed to go all the way around to here. It's a really big answer. So it's not just 60, which is pi over 3. And if you don't have those memorized, I'll write them down for you. 30 is pi over 6. 60 is pi over 3. 45, pi over 4. Oops. And those are the big ones. But also, I guess 90 is pi over 2. 180 is pi. But anyway, back to this. Pi over 3, but not pi over 3 because it's a bunch. This is 3 pi over 3. And then it's really tempting to just go 4 pi over 3. The way I think of it is this. That's 3 pi over 3. That would be 6 pi over 3, which is clearly too much. Back off 1, and I'll be at 5 pi over 3. All right. How many of you knew the answer was 5 pi over 3 before I said it? Nice job. See, that forces you to know so much circle trig. So I wanted to get there today. But now, for the rest of the day, it is work time on this packet. And I've gotten you through, you should be able to answer the very beginning of trig, and then I'll go through the rest of that trig stuff tomorrow. And if you want to get into domain and range, I guess, you know what I'd like to? Let me just tell you one more thing about domain and range. To remind you, sines looks like this, and cosine also looks like this. And so you remember their domain is like from left to right. Well, the domain on sine is from negative infinity to positive infinity. But the range on sine and cosine is the highest and lowest that they go. So the range on these guys is negative 1 to 1, and it can touch them, so brackets. Now the only tricky thing is this is like, oh, I stretched it, it's twice as tall. So it's going up higher and lower than usual. So I'd make a little sketch for myself what they look like. And that might help you figure out their domain and their range. Interval notation just means things like negative infinity, comma, infinity. All right, that should get you through the beginning of the trig part. And then I'll finish the trig stuff tomorrow. And that's all I got for you for today.